Hello, and welcome to part 2 of meeting 4, Reconstruct the Frieze. So the team gets basic Sankofa shapes. And the first question you ask your students is, what do you notice about them? So each small team will get these birds. And first, give them at least 30 seconds to 1 minute or so to check the shapes. First, they should notice that not all the shapes are exactly equal, right? Because this bird is facing different direction than this bird. And then what they can do is try to move them around and say things like they can have different orientations. But like if you're allowed to rotate and try to see how many shapes, like different shapes you have, you'll end up with just kind of two groups. They could also notice things like this, that these are mirrors, right? Vertical mirrors. But they could also try to do a horizontal mirror. So if they do this and try to rotate it, then they'll do that. So flipping is just one-sided tiles for this activity, but from there, you can generate the flips. So every shape will have a vertical mirror and a horizontal mirror. And of course, rotations. That's just natural with your fingers, with your hands, you rotate around. Then they try to build a Frieze pattern. This is open exploration, also just takes 1 or 2 minutes quickly in the tables and in the teams, and just try to create some symmetries. This is low ceiling activity, so before we have them match these activities, we do more a low stakes part, the B, and just try to do anything that really comes to your mind. So one team could just say, I'm just going to repeat that. And then you could ask them about symmetries. They could say, I don't see any symmetries, but then you could say, this is infinite, remember? Supposed to be infinite, so translation symmetry, right, will be happening. So the pattern repeats. Then some other teams that sees this could have just an idea. They could say, what if I rotate every 2? What would happen? Right? And then they could say, oh, they have now a rotation symmetry. And you could ask of the whole shape or the whole Frieze pattern or just 2 tiles. They could first say maybe just these 2. But they could also say, well, once you have 2, since you have the same structure kind of alternating, then you could also have even more, right? Even more rotation symmetry. And since this is meant to be infinite, you could take a lot of shapes and put them like this, forming this alternating pattern. And just try to make sense that, just copy it here, that when you rotate, you get exactly the same shape. Well, you have to actually add one more. It's infinite anyway, so it's only what matters is to identify the rotation point, right? What's the point that doesn't rotate? Okay, let's do it now, hopefully. If we do a 180, yeah, we match. It's a perfect match. Don't spend too much time on this, but spend some time because this really builds confidence to what follows, because now kids have tried a little bit. Another team could take this shape and say, I'm just going to do this, for example, and repeat all over. And then you would be talking about vertical line, infinitely many vertical line reflection symmetries, right? Because if you flip it, then you get exactly the same shape. So it has symmetry. So that gives us a sense of almost no symmetry, just repeating, and then a lot of possible symmetries. Some students may also get creative here and say 2D. Again, you're investing in what follows, so you're not really wasting time, but you're strategically having kids take agency and owning what comes next. And what comes next? So you look at these 10 Frieze patterns, so these 2 plus the ones here and etc. So there's lots of patterns, so from 0 to 9. And for each of them, you build a new Frieze just using your birds that has the same pattern. So what does it mean to have the same pattern? That's of course the most interesting point. What's the same pattern? Is it the same shape, or is the same size, or what is it? So you just tell them it's the same structure, the same symmetries, it's the same essence. So you must identify the same symmetries, not add any, and not miss any. Capture exactly the same symmetries. 0 and 1 are meant to be kind of easy with some scaffolding. You could ask kids if these are lines of symmetry or not, or what they mean. In this case, these are not lines of symmetry. So you can connect to part 1 because you would flip the dog, will change direction. So this is just a repetition. And this is very easy to replicate with the birds. You would just put birds. And this has some symmetry already. So kids would probably know what to do here to just flip this shape or, mirror it vertically with the vertical line. So let's take a look quickly at the solutions. So again, you can demo 0 and 1 and do it yourself. And so that's the first type, 0, the T Frieze patterns that don't have much symmetry, only translation symmetry. If a team does this, another team could say, no, it's wrong because the dog is facing left and your bird is facing right. But you could say it's still the same structure. So in essence, it's the same Frieze pattern. It has the same symmetries, just translation. So there's multiple solutions. So this is also a good solution. This is also a good solution, or the bird looking the other way. An example of incorrect structure would be introducing some new symmetry that didn't have, the old pattern didn't have. For example, this pattern here, this Frieze pattern going left to right, has a horizontal line of symmetry. Because if you can flip it, you can reflect it, you get the same pattern. But neither of these have, right? They don't. If you just flip it, for example, this whole shape, let's do it. If you just rotate it like this, then you don't get this nice version. So in the teaching guide, you can see all the types. TV would be just vertical symmetry and translation, of course. And they'll discover how to do it like this or like this. There's several ways. But for example, not like this. This would have H line, horizontal line. These, they could think they did it because this has the symmetry, but they're introducing rotation symmetry. That's not good, right? They're introducing glide and rotation. These don't rotate well. This rotates well. So you would tell the mentor or the student, I think I spot some new symmetry, guide them to discover that they're doing reflection. And then you challenge your students to do reflection here. Not gonna happen, like here the dots go, the black dots kind of go up. And here the dots just would point in the wrong direction. Just rotation, this, and translation, of course, but they would do it. All symmetries, this pattern number 2 has all symmetries, and this is how they do it. They take the basic bird and they do 3 more. So that's an important point. Whatever shape you have in the world bounded shape that doesn't have any symmetries, if you just flip it like this and then flip it like that, so you create 3 more friends somehow, then the new big shape has all the symmetries that you're looking for. It has rotation. Well, yeah, it has the 2 mirrors, so it's all good. So you can create this. So this is an important point here. This has only the glide reflection. So meaning that if you take your basic pattern, you flip it with respect to horizontal line, and then you translate it. So you move it to the left or to the right amount, you get the same shape. So it's like a cheating translation. It's translate, but before you translate, do a flip, do a horizontal line flip. And the birds here would do it well. You could also be creative and take 2 birds like this as your basic unit, and then do the glide reflection this way, and so on. This has just horizontal and glide. So it's a horizontal line. You could do it like this. Okay, and in the video I won't explain, but I ask you as a challenge to classify number 7. What kind of symmetries do you see? So try to do it with your commenter, and you can also publish your findings through email or Canvas and let us know. Okay, see you in the next video. Enjoy.